These are your 8-6A notes, and actually they're just your 8-6 notes. There will be no B for this section. So this is the section where we actually solve equations. So we're taking the expressions to equations now. So the previous days we knew how to simplify them, multiply them, divide them. Now we're going to solve equations involving rational expressions. So when we solve equations with fractions, we're going to use our fraction example one more time. This is a pretty complex equation, so you should already know how to solve this. Looking at it, it's a little intimidating because of all those fractions. So one of the strategies I teach kids early on is that any whole numbers make into a fraction, and then if we could really take just an extra step and get rid of all these fractions, make this entire equation bigger. Okay, fractions are just portions of numbers, so they're just really small numbers. But if we could make it a little bit bigger, and by multiplying both sides by a certain number, it can take care of the fractions. So what we do is we decide how much bigger we want to make it. If we make it 6 times bigger, it will take care of that fraction. If we make it 3 times bigger, it will take care of that fraction. That one doesn't really need any taken care of. And if we make it 4 times bigger, we can take care of that fraction. Rather than multiplying by 6 times 3 times 4, it would be best to make it just multiply by one number that takes care of everybody. So I need a number that 6, 3, and 4 all go into. You kind of want to stick to the smallest number so that you don't have really, really large numbers. We just want to make them whole numbers, but we don't need to have hundreds and thousands of numbers. So this is where that least common denominator comes into play again. I'm just going to call it a least common multiple because I'm not going to get a common denominator. I'm going to get rid of the denominator. So a number that 6, 3, and 4 all have in common is 12. I know a lot of people want to say 24, and 24 would work. It's just going to be much bigger. So the reason I can get 12 is if I look at the factors, 6 has factor 2 times 3. 3 can share that 3. And 4 has a factor 2 times 2. So 6 and 4 can share the 2, so we only need one of those. 6 and 3 can share the 3, so we only need one of those, and then we need another 2. So 2 times 3 times 2 does give you that 12 up above. So I'm going to take the time to go ahead and multiply this whole side by 12. And I'm going to multiply this whole side by 12. But when we do that, I'm going to distribute it to everybody. So the step is a little long, but it shows you exactly what's going on. So I'm going to multiply the first problem, 12 over 1, the first fraction, by 5, 6x, plus 12 times 1 times 2/3 is equal to, on this side, 12 times 1, or 12 over 1 times 2, minus 12 times 1 times 3/4x. Okay, so actually, this one minus right here, I'm going to multiply by a negative 12. So I'm going to think of that as negative 12. So when I do all this multiplication, you can clean it up first before you do the multiplication, because when you multiply fractions, you can simplify before you do the multiplication. So I can see that 6 and 12 have something in common. That's why I picked 12. We're on purpose getting rid of the 6. So the whole goal here is that we can simplify and cross off and make all of these denominators into 1s. So 6 goes into itself once, 6 goes into 12 2 times. So really, I'm only multiplying 2 times 5 times x, which makes 10x. The next quantity here, 3 goes into itself once, 3 goes into 12 4 times. So I have a positive 4 times 2, which is positive 8. The next one, nothing's going to cancel because they're already 1s, so I just multiply. I still have to multiply it by 12. And then the last fraction, the 4 goes into itself once, 4 goes into 12 3 times. I'm going to circle that negative, so I have a negative 3 times a positive 3 times x makes negative 9x. So look at how nice, in that crazy step of all that multiplication, taking that extra step to multiply everything by 12, I have a nice, clean, easy equation. So I'm going to add 9x to both sides to bring the x over to the left-hand side. And within the same step, we could even subtract 8 to bring the numbers to the right-hand side. So I get 19x is equal to 16. These cancel. And then divide by 19, divide by 19. x is equal to 16/19. Now, I know the answer is not pretty, but you can't force an ugly answer to be anything but ugly. Okay, so the problem was ugly. Most likely our answer could, in fact, be ugly. So, but it simplified the process in which we got our answer, which is a lot easier. So a couple of things. We're going to find the least common multiple. We're going to multiply both sides by the least common multiple, and then solve equations as usual. So today, since we're solving, we're going to get an actual answer. We're not going to get a quantity. We'll actually get a number for our answer. So really quick, some definitions and terms. A rational equation now is different than an expression. It's just setting an expression equal to each other. So we have an equation. We have equal signs. You're going to factor every denominator and find the LCD. Multiply both sides by the LCD. You could call it the LCM. We're not going to get a common denominator. We're going to get rid of the common denominator. We're going to solve the equation as usual. And then unfortunately, you have to eliminate the solutions that are excluded. So we still have to look at those excluded values. We haven't done that in a couple of days. But if they're excluded and we get that number, we have to throw it out. So just something at the very end you kind of have to look at. Okay, so let's go ahead and try this. You can actually in your head have the excluded value right now. My excluded value is that x cannot equal positive 4. Because if x equals positive 4 and I plug it in to this denominator here, I get 0 in the denominator, and that's not allowed. So if my answer to this equation is 4, I got to throw it out. So looking at these values, I have a 7, an 8, and an x minus 4. So my least common multiple, 7 and 8 don't have anything that they can share, so I have to do 56. And then I also, x minus 4 needs to be part of that denominator. So if I multiply both sides of this equation, so I'm going to multiply this side by 56x minus 4, and I'm going to multiply this side of the equation by 56 times x minus 4. We should get rid of all those denominators. So this next step is pretty big, but it's important. So we're going to do 56 times x minus 4 over 1 times, and then we're going to write down the 6/7 minus 56x minus 4 over 1 times 3 over x minus 4. Probably didn't need that parenthesis there. Is equal to, and one more time, 56 times x minus 4 over 1 times 7/8. So notice I put that negative with the 56 because the subtraction sign, you want to make sure you don't forget about it. So now we're going to go through and eliminate. 7 goes into itself once, and 7 goes into 56 8 times. So actually, I have to multiply 3 things together. I'm not going to make my brain work that hard. I'm going to take the two numbers, 8 and 6, multiply them together, and I'll take care of the other multiplication later. Okay, you try to do too much at once, you make mistakes. So just write that down, let it go. Let's finish the first task of just crossing things off. X minus 4 is canceled. So all I have here is a 3 times a negative 56. And 3 times negative 56 is a negative 168. And then that equals, the 8 goes into itself once, 8 goes into 56 7 times, so I actually have 49 times x minus 4. Don't forget the x minus 4. So again, I'm just going to leave that on the outside. So now that I have all of the denominators, if you look, all of my denominators canceled to 1. That's what's supposed to happen. Let's go ahead and distribute this. 48x take away. I need to do 48 times 4, negative 192, plus 68. I don't think that's plus 68. I think that's a sloppy. Just give me 1 second. Is that my sloppy negative? That's a negative 168. Minus 168 is equal to 49x take away 196. So I distribute the 49, distribute the 48, and now we can solve. So I'm going to bring the 48x over here, subtract 48x, so x is positive. If I bring the x to the right, I'm going to bring the positive 196 to the left. I probably should have put these together first. And so I get 4 minus 168 is equal to x. I probably should have put those together first. So now I'll put them together. 4 take away 168 is a negative 164. And there you have it. I didn't get 4, which is good. So this is my solution. Next problem. All right, so we're not going to factor the numerators. We really don't care about factoring the numerators. We just got to get rid of those denominators. The reason we don't want to factor the numerators is we're going to have to multiply. So why undo the multiplication? So the first one, x plus 5. The last one, x plus 3, those cannot factor. And I just bet that maybe the middle one has something to do with 5 and 3. What multiplies to give me 15 and adds to give me 8 is in fact x plus 5 and x plus 3. And so when I look at this, the first one needs an x plus 5. The last one needs an x plus 3, and they can share for the middle. So my least common multiple is x plus 3 times x plus 5. So we're going to just always write that down. Now we're going to go through and we're going to write down over and over again. So x plus 3 times x plus 5 over 1. Since we're multiplying fractions, it's a good habit to get into. Times 2x over x plus 5, this is my original problem, minus x plus 3, x plus 5. So that minus out in front there is going to be a negative 1. I'm going to treat it like a negative 1. Times x squared minus x minus 10 all over x plus 5, x plus 3. One more time. This equals x plus 3 times x plus 5 all over 1 times 3 over x plus 3. Now I know it takes some time, but if you show good work, it's a lot easier. So be neat about that step. Okay, so now the fun comes in. This becomes a 1, cancels the x plus 5, so I only need to multiply these two. Okay, I'm just going to write it down, or I can distribute as I write it down. 2x squared plus 6x. Next quantity. Everything in the denominator cancels with everything in the numerator except for that negative 1. So I'm going to apply that negative 1 to that entire quantity. So it's going to become a minus x squared, a plus x, and a plus 10 equals x plus 3's cancel, and so all I have is 3 times the quantity x plus 5, which is 3x plus 15. So now we can solve. I see some squared terms, and I see that the squared terms aren't going away. I have a negative x squared and a positive 2x squared, leaves me with a positive x squared. I have an x and a 6x makes positive 7x, and I have a plus 10. So I'm just cleaning up the left-hand side. Right-hand side's all clean. Now, if you remember, way back in Chapter 4, we learned how to solve quadratics. We can solve by factoring, we can solve by completing the square, we can solve by graphing, we can solve by the quadratic formula. So let's just see which one applies here. I usually look for factoring because it's the easiest and fastest. If not, we can do the quadratic formula. Both instances requires it equal to 0. So I'm going to subtract 3x to bring it over with the 7x, and I'm going to subtract 15 to bring it over with the 10. So x squared plus 4x minus 5 is equal to 0. What multiplies to give me negative 5 and adds to give me a positive 4? How about x plus 5 and an x minus 1? A negative 1 and a positive 5 multiplied to give you negative 5, and they add to give you 4. Using ZPP, x plus 5 can be the one that's equal to 0, or x minus 1 is equal to 0. ZPP is a zero product property. I have a product, a multiplication that equals 0. Therefore, one of the numbers that I'm multiplying must be equal to 0. So if x plus 5 is equal to 0, then x must equal negative 5. If x minus 1 is equal to 0, x must be equal to 1. So I got two solutions. I've got -5 and +1. But let's go ahead and scroll up and just see where after I factored, my excluded value should have been, this tells me that x cannot equal -5. And this tells me that x cannot equal -3. I believe -5 was one of our answers. So we simply just have to cross that off. And so we only get one solution, and my solution is 1. If we crossed off both of them, then we would say there is no solution. All right, I'm going to let this one go. And here is a work problem. So work problems end up being in this section. It's sort of a story problem that kids really struggle with. And the reason they struggle with them is they try to set it up like a normal linear equation. There's nothing linear about this. So Nolan and Jacelyn, interesting names, mow lawns together. Nolan, working alone, can barely complete the job in 4.5 hours. Jacelyn, on the other hand, could complete the job alone in 3.7 hours. So how long does it take them if they were to do the job together? Obviously, it's not just their average, okay, because Jacelyn's working harder than Nolan because maybe Nolan is messing around, maybe with the mower. So regardless, we have to figure out when they work together, how quick would they have the lawn mowed. So this involves time. So the time it takes Jacelyn is time divided by 3.7. And then the time it takes Nolan would be time divided by 4.5. So you're actually looking for the rate. Distance equals rate times time. Okay, you know the time. We just don't have the rate. Or I'm sorry, we know like the distance or how much you can complete it. So they're completing the same job, and this one completed job is 1. So this is the fraction that she's cutting. This is the fraction that he's cutting. She's cutting more because when you divide by 3.7, it's a bigger number than if you divide by 4.5. But in the end, how long will it take them? So when you find a common denominator between ugly decimals, you just multiply them together. So we take 3.7 and times it by 4.5. We get the least common multiple to be 16.65. So I'm going to multiply both sides, this whole thing, by 16.65. And also the 1. A lot of people forget to multiply the 1 by 16.65. Now what's nice, how did I get 16.65? Well, 16.65 over 1 times t over 3.7 plus 16.65 over 1 times t over 4.5 is equal to, and I'm just going to write it out, 16.65. But what's nice about this is because we multiply, I know 3.7 goes into it 4.5 times. So the first one becomes 4.5t. And I know that 4.5 goes into it 3.7 times because that's how I got the number. I multiplied those two numbers together. And it equals 16.65. So 4.5 plus 3.7 is 8.2. T is equal to 16.65. When you divide by 8.2, divide by 8.2, you get 2.03 hours. So time is equal to 2.03 hours. So if they work together, they should be able to complete the job faster. Make sense of it? It should be faster than both their times if they're working together. All right, so what I need you to do here, LCM, I need you to just find the LCM for the lesson summary, and then I actually want you to go ahead and solve. Good luck.